Now, slope of a line, okay guys, the slope of the line is the relationship between what the y-axis is and what the x-axis is. Rate of change of y equals 3 times the rate of change of x. Let me describe what I mean here. If I get the slope of this using the slope formula, that will be 1, 3, 0, 0. You do your standard y2 minus y1 over x2 minus x1. You find the slope of the graph to be 3. Nothing new there. Okay, so this entire slope of this graph is 3. Okay, and this is the line y equals 3x. Now, do you know why there's no, do you know y equals mx plus c? The c value is 0 because it's crossing through the origin, okay? Now the slope is 3. The rate of change is what's called the slope. For example, if I change the y-axis into distance, and I change the x-axis into time, this means that the key here, just let me continue here, right? The rate of change. This means that the rate of change with distance to time is going to be what? If distance is measured in meters and time is measured in seconds, what's the rate of change going to be? 3 meters per second. If I were to put distance and time. If I did a population growth graph where I said this here is time in months and this is population, what can you say then? The population in number of people. What can you say the rate of change is? 3 people per month. So you can see that slopes actually have context to them. If you can model a function or a graph, you can then use slopes to explain the change. Is everybody with me so far? The key word here is slope. Excuse me. The slope of a line will give the rate of change of the variable and the variable axis. Alright guys, so the key word here is slope. The slope of a line will give the rate of change of the variable on the x-axis with respect to or compared to the variable on the horizontal. Whatever is here, population with respect to time, distance to respect to time. Whatever is on the y changes with whatever is on the x, okay? That's the gist of what we have here. Now, another problem is, consider the following graph. The problem with the following graph is that it's constantly changing slope. Would you agree with that? It's not a straight line. What we construct is what's called tangents. Let's say, for example, this here is x equals 1, and we want to find out what is the slope at x equals 1. The slope at x equals 1, and we're to zone in on it. The slope at x equals 1 is what we call a tangent, and a tangent is only allowed to touch it once. That's how we get the slope, okay? Now, the slope of a curve at a point, so for example at x equals 1, is equal to the slope of the tangent at that point. As we move along the curve, the slope of each tangent changes. You see the way the direction is constantly changing. And when it reaches its turning point or its minimum, the slope is 0. Any line going directly across has a slope of 0. In other words, the rate of change of y with respect to x changes. We need to find a method of finding the slope of a tangent at each point on the curve. The method of finding the slope of a tangent at any point on the curve is called differentiation. So for example, if I was to model this question, on the population of polar bears, okay? Polar bears, and on the x-axis I'm going to go, this is time in months. The type of question I could ask you here would be like this, okay? The type of question I could say is, you have to find out what is the increase of the polar bears in 2 months. You'd have to find out the slope at 2 months. Or you'd have to find the slope of the tangent at 2 months. And this would mean you'd have X amount of polar bears. It'd be a negative slope, wouldn't it? So you might be losing like minus 20 polar bears per month. That's a context question. I can ask you something like that. So, rate of change is 2 well-known changes of slope of a line are slope of the line and speed, where slope of the line is y2 minus y1 over x2 minus x1. Speed is distance over time. So guys, let me explain how to do this. First of all, you're going to sketch a graph. this graph is going to be sketched as shown here. Okay? So, what I'm going to do is I'm going to go to GeoGebra and I'm going to draw this graph. You'd obviously use your calculator function and draw it out. You've done this already. So look what happens. Y equals x squared. Okay? So this is y equals x squared. And it's located here. And what does it ask me to do? From what values? Minus 1 to 5. Okay, that means I need to make this lower. Okay, there we go. Minus 1 to 5, okay? Now, what we can see here is this is it here. Okay? Now, what I'm going to do next is, before I even take this across, what I'm going to do is I'm going to do what points it wants me to put in. It wants you to put in the points x equals 1, yeah? X equals 1, x equals 2. So I'm going to draw these points out for you now, okay? What's going to be is, on the calculator, it'll give me these points. So if I was to do the calculator function, I'm probably going to do it anyway. It's going to be y equals x squared. And then I'm going to go from minus 1 to 5. Now if somebody will do that for me as well, that'd be great, because I'll need to draw out these points. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. So it wants me to draw everything but 3. So I'll show you now. So what it wants me to draw is 1, 1. I'm sorry. 1, 1. This is the first one. What's the next one it wants me to draw? 2, 2. Oh, sorry, 2, 4. Okay, after that? 3, 9. After that? Oh, sorry, yeah, 3, 9, yeah. After that? 4, 16. And after that? Okay, now, looking at these here, okay? What I'm going to do now is just quickly take the snapshot of this. Now, not snapshot, the snapshot. Okay. Now, what's going to happen here, guys, is the following, okay? What it asked me to do is, it asked me to join 1 to 5. So, 1 to 5. So, do you see the slope of that one? Yeah? And now it asked me to join B to D. Now, these two lines are what? Parallel. Now, the reason why they're parallel is we're trying to find out where x equals 3. What's equidistant from 3? What's equidistant to the left is 1. Therefore, what's equidistant to the right is 5. And so, if I got the distance between the x equals 1, if I got the slope from x1 to x5, it will then tell me the same slope as that between x2 and x4. Why is x2 and x4 the same? Because it's the same distance left or right of point C. So for example, let's put down these 2 points. It's 1, 1 and 5, 25. Let's find the slope of this. x2, y2, x1, y1. What's going to be is 25 minus 1 over 5 minus 1 gets me 6. The slope is 6. Okay? Join the points on the graph where x equals 2 and x equals 4. Then calculate the slope. So once again, it's going to be 2, 4 and 4, 16. And it's going to be y2 minus y1 all over x2 minus x1. And that's going to be 6 minus 4. Oh, sorry, what is it? Sorry, 16. 16 minus 4 over 4 minus 2. 12 over 2. Once again, the slope is 6. Now, what that means there is that if we were to put a tangent at C, what do you think the tangent would be? The tangent would be a slope of 6 as well. Now, this will only work if the 2 points you take are the same distance from the point you're looking for. In this particular question, we're looking for x equals 3. That's why we chose 1 and 5 and 2 and 4. Can anybody tell me 2 other points I could choose that would also work? 0 to 6. Because they're both a gap of 3, they're the same distance away from x equals 3. What would be the next point I could choose? Minus 1 and 7. Do you have enough evidence to deduce that do you have enough evidence to deduce the slope at the point where x equals 3? Do we? We do, because they're going to be the same slope. And if we make this gap smaller and smaller and smaller, what happens? It's still going to be a slope of 6, provided the 2 points are the same distance away from x equals 3. Alright, now there's another way of thinking of this, okay? Now, this is the same question, or a similar type question, okay? Sketch the graph y equals 8 minus x squared from minus 4 less than or equal to 4. So will somebody do this for me, please? Will somebody put that into the calculator? 8 minus x squared. Okay, start at minus 4, end at 4. Okay, step 1. Will somebody take down all these, call out these points to me in a second, okay? So, what I'm going to do first is draw 8 minus x squared. So what's y equals? 8 minus x squared. Okay, here it is here. And it's going in between minus 4 and 4. So I should probably maybe 2's. Yeah, that's perfect. Okay, that's as good as I'm going to get this. Now, that's it there. Okay? Now, what we're asked to do is, we're asked to, first question is draw an axis of symmetry. Does anybody know what an axis of symmetry is? So, an axis of symmetry is a vertical line that cuts it in half perfectly. What line cuts it in half perfectly? The y-axis, or the line x equals 0. Okay, cuts it in half. No bother there, okay? Now, next thing. Show that the point 2, 4 is on the curve. If it's on the curve, it satisfies the equation. We can see that 2, 4 is on the curve, but how do we prove it? When the output is 4, and the input is 2. 4 equals 8 minus 4. 4 equals 4. This means it's on the curve. Join the points on the graph where x equals 1 and x equals 3 and calculate the slope. Okay, so x equals 1 is here. X equals 3 is down here. Okay guys, I'm not going to, you know what we're going to do. We're just going to put in these 2 points. We know what these 2 points are, don't we? Because they're on our graph. It's going to be 1, 1, 7 and 3 minus 1. 1, 7 and 3 minus 1. You're going to get the slope in between the two of them. The slope turns out to be minus 4. Everybody happy with that? Is everybody happy for me just to put down what the slope is as opposed to doing y2 minus y1 over x2 minus x1? Okay? Yep. Thank you.
Thanks.
Okay? So y2 minus y1 over x2 minus x1, okay? Now, same deal. X equals 0 and x equals 4. X equals 0 is 0, 9. X equals 4 is going to be, anybody know the point for x equals 4? 4 minus 8. Once again, you get the slope between the two of these, and what does the slope turn into? Sorry? Minus 4. They're meant to be parallel. It just happens that I haven't drawn them parallel. So that's going to be minus 4 as well. Now, it says deduce the slope at P. So P is this one here. What happens when we make these gaps smaller and smaller? We're still going to get slopes of minus 4. And then eventually we're going to get so close that it still is minus 4. Show that minus 2, 4 is a point on the curve. So lads, how do I show that minus 2, 4 is a point on the curve? Replace 4 with y with 4 and x with minus 2. Once again it's going to turn into 4 equals 8 minus 4. 4 equals 4. What can we say about the slope at 2, minus 2, 4? What can we say about it? It's symmetrical of the slope on the other side. So if one of them is minus 4, the one on the other side will be plus 4. And that's how we deduced it as plus 4. Because they have the same slopes. It's like a mirror image of each other because of the axis of symmetry. Okay? Now, so lads, look at this. Okay, this one here. Draw the function, lads, draw the function y equals x cubed from 0 to 4. Okay, so once again, you're going to go to your calculator function and you're going to draw the y values from 0 to 4. So will somebody do that in the calculator and then call me at the points, please? Y equals x cubed. Now that's from 0 to 4. Now guys, what we can see here is that it's quite a steep graph, so I'm going to have to make this a lot smaller to fit everything in. Okay, now finally have fitted everything in, I think. I have, just about. Now guys, what points does it ask me to draw on it? Ask me to draw the points 1, 1, 464, 327, 2, 8. Will you start calling out those points for me now in a second, please? Okay, so what's the first one? 1, 1. Sorry, yeah, you're right. I have it drawn out already. But I'm on part 2 now, which is asking me to. So what is the point when x equals 1? 1, 1, isn't it? Yeah. What about, what's the next one they want me to draw? 464. What? 464? Okay, after that? 327. Sorry? 327. 3 and 7? 27. 3 and 27. And after that? 2, 8. Yeah, and? Now, guys, look at this. I'll do this by graph, okay? If I join A to B, okay, it's that slope there. If I join A to C, it's that slope there. And if I join A to D, it's this slope here. Do you notice that they're getting closer and closer? What is it? It's, I have a line here. I'm just going to make a line here for you. Okay, guys. Do you notice that they're getting closer and closer? Sorry. They're getting closer and closer to what I would consider to be the tangents. Do you see this line here? That line there is the tangent. Okay? So guys, you can see that as we get closer and closer and closer, the line, we're going to eventually get the tangent of the line. If I make this gap really, really small, the gap between the 2 points, you can see that I'm getting closer. That's the first gap, which is the biggest one. Second biggest, biggest, second biggest, smallest, and then I'm getting closer and closer to the slope of the tangent. And what does the slope of the tangent represent? The rate of change, as discussed in the very beginning. So, with that in mind, what happens is, it says estimate the slope of the curve. Well, what you do is you do the, you're going to do the slope formula 3 times, then you're going to see what it is at the end, okay? It's going to turn out to be 3, but the other ones are going to be much steeper than that. So the first one is going to be, it's going to be 63 over 3. The first slope is 21. The second slope is going to be 26 over 2, which is 13. And the next slope is going to be, the next slope is going to be 7. Now, actually, interestingly enough, okay, guys, there's actually a series going on here. Look at this. This might be a bit ahead of time. The gap between the first slope and the second slope is 8. The gap between the next slope is 6. And the gap after that is going to be 4. 8, 6, 4. And that's how we estimate that was 3. Okay. Okay. Now, this one here is let P equals 3 and U be a point on the line y equals x cubed. What I'm going to draw is the function y equals x cubed. X squared, sorry. Now here's y equals x squared, right? And this is it here. Okay? So we can see it's a normal U-shaped graph. The rate of change is always going to be tangents. Do you understand? So the tangent is going to give us the rate of change at that point. So what we have to do is we have to figure out how do we find a general procedure for finding the slope of a tangent. Okay? So what question 1 asks us to do is, question 1's asking us to do is, let 3u be the point on y equals x squared, find the value of u. U is the output. U therefore equals 3 squared, this equals the point 3, 9. We know that 3, 9 is on this graph. There it is there, 3, 9. Okay, moving on. Q is a point very close to P. T is a very tiny possible value. If the x coordinate of Q is 3 plus T, find its y coordinates. So the x coordinate is 3 plus T. We have to find out what the y coordinate is. What do? U equals 3 plus T squared. Oh, sorry, not U, just that point. That's going to equal 9 plus 6T plus T squared. Now, what you imagine is this, guys, okay? What we have now is the point 3, 9, which is here. And now we have a point that's really, really close to it. And if we link these 2 points together, what happens? It more or less mimics the tangent, doesn't it? Okay? So it's very close to being the tangent because the 2 points are so close together. Now, what happens here is, find the slope of PQ in terms of T. How do we find the slope? Well, the slope is, we know that this one here was, what was it again? It's going to be 9 plus 6T plus T squared. And this one here is 3 and 9. To find the slope, it's x2, y2, x1, y1. We then use the slope formula. And the slope formula is going to be y2 minus y1 all over x2 minus x1. Now look what happens. Okay? What happens is this. We're going to get 9 plus 6t plus t squared minus 9 all over 3 plus t minus 3. The 9's will cancel. The 3's will cancel. And we're going to be left with 6t plus t squared all over t. Divide by t and we get 6 plus t. Okay? Huh?
Just move across t.
Yeah, so the slope is 6 plus t. Now look at the next part. Done. If t is 0, what will the slope of PQ now represent? What does T represent again, guys? T represents the very small... Sorry? It represents a very small change. So, for example, if I was to... I just need to do a new one here for a second. And go back to GeoGebra. And look at this. Okay? I'm going to really zone in on this, okay? Now, when I drew them, they were very close together. Okay? So what it wants me to do is, it basically wants me, imagine this is the gap of T right now, yeah? And their slope is A joining to B. Okay? But if I make the value of T really small, what I'm basically doing is I'm putting them so close together. If T is 0, there is no gap. Or if T is a number very close to 0, there is no gap. So in essence, I'm actually getting the tangent because there is no gap. And remember what we said in the last question, as the gap got smaller and smaller and smaller, the slope looked more and more like the tangent. And now all of a sudden when T is 0, we'll probably be getting the tangent, okay? So, what happens next is, why can't we let t equal 0 before we do part 3? What happens if you do part 3? So if t equals 0, guys, what's the slope? Slope is going to be 6. Alright? And what you'll find out is, if I draw a line of slope 6, y equals 6x, there's a line of slope 6. And look what happens if I move it into position at A. What is it? It's a tangent. And we can see here, look, I'm just going to zone right in on it. You can see now that it's trying to get really close to it now. And we can see that it's a tangent, can't we? And we can see that A and B is such a short distance that it's basically the slope of the tangent as well. Or if I made a point that's really, really close to A, what would happen then? It'd be even closer to the value of the tangent. Okay? So look at this. So slope is 6, okay? Now why can't we let t equal 0 before what we do in part 3? The problem is, what happens if you have t equals 0 on the bottom? It's undefined. Alright.